Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we're going to continue talking about the receive method, and we're actually going to create more than one actor and have our actors talk to one another. So I'm going to make another actor class, so I'll put this one below the first one. And we'll call it our counting actor. This is a simple example where I want to have two actors count down. So for each one, I am going to give it a name. That way we'll be able to have it print out its name and tell us that it'll tell us which one it is that's actually doing the counting at that time. Because it's an actor, I need to give it an act method. And we're going to do something similar to what we did up here, where we're going to create, we're going to create a flag and have a while loop and a receive. Okay, and I want to have a case for countdown where it gets passed an integer, and it will also be nice to have one for quit, where it sets the flag to false. We can go ahead and add a case class for countdown, and that will remind me that my syntax, I don't need to specify that's an int, it's specified up here. Okay, so what should happen when an actor gets a message to count down? Well, first thing they are supposed to do, well, they should check the number. So we're going to count down, I guess, count down to 0. Actually, I'll go ahead and print either way. So print line, the n. And then if n is greater than 0, we're supposed to continue counting down. So, but I want to have this countdown with the other actor who is the one that sent us this message to count down. So if n is greater than 0, then I want to send back a message to that actor. Well, how do I know what that actor is? It turns out that all actors know the value of the sender of the message. So you can send something back to them like that. Okay, so when this message is received, I print out the n, and I check to see if it's sufficiently large, and if it is, I send a message back with one smaller n. And so this will go back and forth between our actors. We can go down here into our main. We'll make one counting actor named thing1, and we'll go ahead and start it. And we'll make a second one called thing2. Oops, and when they print, let's actually have them print out their name plus the value, so that we can tell the difference between who it is that's doing the counting. Now I need to send one of these, either thing1 or thing2, a message to get them to initiate the counting. Problem is I can't do that with countdown. And the reason I can't do that with countdown is that countdown is expecting that the message comes from a sender. So I need to have another message type in here, a case class for start counting, and it's also going to take an integer to count from, but in addition to that it needs to take a counting actor, and more generally we just need an actor. It'll wind up being a counting actor. In fact, maybe we can specify that just to make sure no one passes in the wrong type of actor. And now we can put a case in here, start counting, is going to go ahead and do the same print line, but then instead of doing sender's countdown, oops, start counting needs some arguments here, in and our counting actor, we're not going to bother with a check here. We were told to start counting, so we're just going to assume that we can do that and that we can call on the other actor. But as I mentioned before, we have to specify the other actor here because we somehow have to get each actor to know about the other. And we can do that through the message. So if I take counter 1 and send them a start counting method, or start counting message, sorry. Let's have it start counting down from 10, and we're going to tell it to cooperate with counter 2. We can run this, and you see that indeed it goes, so thing 2 prints a 9, thing 1 prints an 8. We do not seem to have gotten thing 1 printing the 10. Oh yes, yes we did. And this is where, so this is worth spending some time talking about. Remember, all of these actors are happening across multiple threads. We don't know the exact order of things. We know that you won't do anything until you get a message, and so if there's some sequence of firing messages like this counting, then that specifies the order that things are going to happen in. However, whether SA gets, our simple actor gets its message first, or whether counter 1 gets its message first, we don't know. And indeed what happened here was that the counter 1 got its message first, but then before it counter 2 handled the message sent to it, the simple actor reacted to both of those. And so this is one of these things that's kind of an inherent part of multi-threading, is that you don't know the order that things are going to happen in. Our goal is to keep this well behaved by keeping mutable memory isolated inside of individual actors and making it so that the dependencies between the actors are not going to cause us problems. There is one challenge here, and that is the fact that this program is still running. Well, we can terminate it. It's actually interesting to run this again and see what happens. Oh, this time thing 1 happened between the two messages for simple actor. That's kind of what I wanted to see, if this would change order. Indeed it does. I don't like the fact that that keeps going though, so maybe I should send counter 1 a quit message, and we should do the same thing for counter 2. That way they'll both stop and terminate our program. What happens if we run that? Well, we got the thing 1, and then the simple actor got its messages, but it didn't keep counting. Well, why not? Because apparently they got the quit method before, or they got the message for quit before they got the message for counting down. And in fact, we fully expected that it would not get down to 8. Exactly how this happens, if we were to run this multiple times, we're always quitting before it even gets to the 9. So the first message that happens to be getting to counter 2 is this quit message before it gets the countdown message here. Okay, so that's not what we wanted. We can't quit this way. So if we can't quit that way, how can we quit? Because I don't want to make it so that it's just sitting there forever. Well, we can have it so that at the point where we stop counting down here, our else statement, we can do two things. The first one is tell this actor to stop, and the other one is to tell the partner they were counting with to stop as well. So now if we run this, they count down from 10 to 0, and our program terminates the way that we want it to. So in this video, you have seen how we can send messages between actors. You have seen the sender being used to respond to a message. And this kind of gives you a basic idea of how we would make things work inside of an actor-based system with passing messages around. In the next video, we're going to come back and we're going to talk about the problems that we run into with using receive and how we can get around them in the old Scala actor framework.